Hello, we'll have a discussion about aromaticity. A compound is said to be aromatic if it follows few conditions. The first condition is it must be cyclic, it must be planar, or you can say nearly planar, cyclic, planar, and conjugation. Conjugation means alternate double bonds type, alternate double bond, or a pi bond and a plus charge like this. Conjugation is mandatory. Along with all this, it must follow Huckel's rule. What is Huckel's rule? Huckel's rule is 4n plus 2 pi electrons, where n is equals to 0, 1, 2, 3, anything. 4n plus 2 pi electrons, if it is following, that is called Huckel's rule. If n is equals to 0, the number of electrons are 2. N is equals to 1, 6. N is equals to 2, 10. Like this, 14, 18, all these numbers are called Huckel's numbers. So if the molecule has these many number of electrons, then you can say it can be aromatic if it is following the remaining conditions, that is cyclic, planar, and conjugation. In this case, if it is having 4n number of pi electrons, instead of 4n plus 2, if it is having 4n, cyclic, planar, conjugation. These conditions are as it is, but instead of 4n plus 2, if it is having 4n pi electrons, then that compound is called anti-aromatic. Anti-aromatic means 4n number of pi electrons. If it's a cyclic compound, no conjugation, no Huckel's rule, no 4n, no 4n plus 2, no conjugation, then the compound is said to be non-aromatic. So we'll have a discussion about some compounds and we'll classify them into aromatic or non-aromatic or anti-aromatic. We'll have a clear discussion about all this. Let's go with this. Have a look at this. See the first one. This is just a cyclic compound, non-aromatic. No pi electrons are there, no question. Here you can see 2 pi electrons are there. So it is following Huckel's rule, but this is a single bond and again a single bond. Two single bonds side by side means there is no conjugation. No conjugation means it is also non-aromatic. Here one pi bond is there, so number of pi electrons will be 2. Double bond, single bond, charge, single bond. So here conjugation is there. 2 pi electrons, conjugation, ring structure, cyclic, planar, and all this. So this is definitely aromatic. In this case, there is a minus charge. Minus charge means 2 electrons and double bond means 2 electrons. So total number of electrons will be 4 pi electrons. 4 pi electrons, and this is also conjugation, double bond, single bond, negative charge, single bond, double bond. Conjugation is there and 4 pi electrons are there. So this is anti-aromatic. Have a look at this. This compound is non-aromatic, no pi electrons. This compound is having no conjugation, non-aromatic. But here you can see 2 pi bonds are there. That means 4 pi electrons are there. 4 pi electrons, double bond, single bond, double bond, single bond. So conjugation is also there. 4 pi electrons are there. That's why this is correct. Anti-aromatic. Look at this now. This is having minus charge. This is having plus charge. This is minus double bond and this is minus charge. So total number of electrons are 4 pi electrons. This is double bond. This is single bond. This is a minus charge. So in conjugation till now, a single bond and a single bond. Two single bonds are side by side. So this is again non-aromatic. Here this is one special case. Double bond, single bond. This is single bond. This is plus charge. This is single bond and again single bond. So here also there is no conjugation. So this is also non-aromatic. Look at this. This is double bond, single bond, charge, single bond, charge, single bond. So this is having conjugation is done. So number of electrons are 2 electrons, 2 electrons, 2 electrons. So total number of electrons is 6 pi electrons. So this compound is aromatic. Look at this. This one, 2 electrons, no electrons. So total number of electrons are 2 pi electrons. Who gets release followed? Double bond, single bond, charge, single bond, charge, single bond, and double bond. So this is having conjugation. So definitely this is also aromatic compound. In 5-member rings, we'll go with some compounds. This compound is definitely non-aromatic because no pi bonds are there. Here you see a pi bond is there, but 2 sigma bonds are continuations. 2 single bonds are in continuation. So here again there is no aromaticity, neither anti-aromatic nor aromatic. So this is simply non-aromatic compound. But if it is having a plus charge here, double bond, single bond, plus charge, single bond, double bond, single bond. So conjugation is there. Conjugation is possible, but number of electrons are only 4 pi electrons. So this is becoming anti-aromatic. Double bond, single charge, and single bond, and this one. So this is 2 electrons, this is 2 electrons. So total number of electrons are 4 pi electrons, and this is anti-aromatic. If it is having a negative charge there, double bond, single bond, negative charge, single bond, double bond, single bond. So this is having conjugation, right? And total number of electrons are 6 pi electrons, 2 here, 2 here, and 2 here. So total number of 6 pi electrons. Huckel's rule is followed. Conjugation is there. That's why this is aromatic. Compound is aromatic. Now, have a look at 6-member compounds. Non-aromatic, 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 because no conjugation you can see here. Don't worry about the number of electrons. Here number of electrons are 4, but there is single bonds in continuation. So this is non-aromatic. If it is given like this, yeah, total number of electrons are 6 pi electrons, alternate bonds are there. So this is definitely aromatic. Conjugation is there, and this is aromatic. What about benzine? It is also aromatic. Don't consider this bonds. Aromatic. Benzine is aromatic. Look at 7-member ring. Here plus charge is there. Minus charge is there. So here 1, 2, 3 pi bonds. So 6 pi electrons are present. Conjugation, aromatic. Here 2 electrons, 2 electrons, 2 electrons, and 2 electrons more. So 8 pi electrons are present. Alternative 8 pi electrons. So this is anti-aromatic. 4, 8, 12, 16 type of electrons are anti-aromatic. 2, 6, 10, 14 are aromatic. That must be contain conjugation. Look at this one. The 2 single bonds are side by side without any charges, so there is no conjugation. So this is simply non-aromatic compound. Look at this one. If you see like this, you can feel that alternate pi bonds are there, alternate double bonds are there. So total number of pi electrons are 8 pi electrons. So you can feel that this may be anti-aromatic, but actually this is non-aromatic. The reason is very interesting. This is having a tub shape. Because of the tub shape, it is not planar. Condition is it must be planar, but this is not having any planarity. That's why this is non-aromatic. This is not the structure. This is the structure. This is called tub shape. and this is non-aromatic, 100% non-aromatic. Some aromatic compounds with some heteroatoms we'll see. You can see when double bond is here, a single bond is here, one of the lone pair is participating. At a time, you don't consider two electron pairs of atom. Resonance is not allowing like that. Only one electron pair from an atom at a time can be given. So two electrons here, two electrons here, two electrons here, 6 pi electrons. This is thiophene aromatic. Here also same thing, two electrons here, two electrons here, and any one of the pair you take. So total number of electrons are again 6 pi electrons are there. So this is also aromatic. Aromatic as well as this is also aromatic. So this is oxygen compound, furan. This is sulfur compound, thiophene. The same compound you can write for nitrogen. Nitrogen's lone pair will be there. This lone pair, two electrons, and two electrons. 6 pi electrons are there. So this is also aromatic. This compound is called pyrrole. I will look at this compound. Nitrogen's lone pair is there. This is also aromatic. Don't consider these electrons now. This electron pair won't participate when it is having alternate pi bonds. Pi bond, single bond, pi bond. That means double bond, single bond, double bond. So when double bond, single bond, double bond and conjugation, it won't take the lone pair. So this lone pair is not participating. 1, 2, 3 bonds are there. That means 6 pi electrons are there. So this compound is going to be aromatic. Next, we can have some other compounds having some special structures. I will look at this. If it is the compound, the electron pair will shift like this. So the resonance structure will be like this. Oxygen with a negative charge. This place is having plus charge, and this is a bond. Now look at this molecule. This part. This part is aromatic in nature. This is aromatic in nature. Otherwise, they can ask you this type of structures. In this type of structure, the electron pair you can shift in both the ways, this side or this side. What happens when you are shifting like this? We will have a look. This is the structure. It is shifting this side. So how it will be? 1, 2, 3. These are the double bonds. This will become plus charge now. This will be minus charge. Now look at this particular part. Conjugation is there. Double, single, charge, and single. But number of electrons are 2 and 2. 4 only electrons are there. 4 pi electrons means this is anti-aromatic. This part is anti-aromatic. Similarly, here also 4 electrons are there. This is also anti-aromatic. So this type of cleavage is not correct. That means this type of bond shifting is not correct. So what we have to do? Just think in another way. For example, it is like this. Let's shift like this. So this kind of shift will definitely work out. How? Now you can see this place is having plus charge, this place is having minus charge, and you can see here a pi bond, single bond, double bond, single bond, negative charge. So if you take this particular part, there are 6 pi electrons. So this is aromatic. Here if you consider only 2 pi electrons are there, this is also aromatic. So both sides it is getting aromaticity. That's why it is going to be highly stable. That's why the electron pair will shift like this. Look at this one interesting compound. This is a bond. If it is like this, shifting, let's shift like this. So what happens here? This will be negative charge, this will be negative charge. So this part is okay, aromatic. What about this one? This is having plus charge. No, this is plus and this is plus, this is minus, and this is also minus, right? Because the electron pair is shifting towards this one. So this is aromatic, right? No problem in this one. But this will become minus charge is there, means this will become anti-aromatic. This is also anti-aromatic. So shifting of electron pair like this is wrong. Instead of that, shift like this. So how it is going to be? This will become single bond. Here minus charge, here plus charge. Here minus charge, here plus charge. So here we can see total number of electrons are 6. 2 electrons, 2 electrons and 2 electrons. So this is aromatic part. Here also this part will be having 2 electrons only. This is also aromatic and this is also aromatic. So you need to check whether it is having aromatic nature or not by shifting the electron pairs also. I just wanted to include one more line here, that's about stability of cyclopropyl carbocations. Whenever cyclopropyl group is attached, we say this is one special and most stable carbocation. The reason is because of this kind of shifting. When this electron pair is shifting here, so it becomes like, I'll show you again, CH2 plus. So what I am doing here, I am shifting like this. So this bond will be CH2. This is plus charge, right? This is a resonance structure. Or if this electron pair is coming like this, double bond CH2, this place will be having plus charge. Okay, so based on the shifting, we can explain this one. This is called dancing resonance. Because of dancing resonance, these are going to be highly stable. So these are few important lines. Along with this, you can take naphthalene type of structures. This is stable, aromatic. Total number of electrons are 10. You can have a look at this. When you compare with the previous one, this is little more stable. The reason is we are having two benzene rings here. This is also having 10 pi electrons, aromatic in nature. If three rings are there, this is called anthracene. Total number of electrons are 1, 2, 3, 4, 5, 6, 7 pi electrons are there. 7 pi bonds means 14 pi electrons are there. Done. Look at this phenanthrene. Same 1, 2, 3, 4, 5, 6, 7. That means 14 pi electrons are there. This is when you compare with the previous one, this is little more stable because this is a benzene and this is a benzene. Similarly, we should know about these kind of structures where more than one ring is present, that like naphthalene and anthracene. Last one, we'll go with one more example. This is a biphenyl. This is another phenyl one. So this is aromatic, this is aromatic. When these are present, they are in different planes. That's why this is going to be highly stable. This is also aromatic and aromatic. Overall, this is going to be aromatic. Biphenyls are aromatic, right? Hope you understood all these points. When a compound is given and asked whether this is aromatic or not, you have to check like this. I'll give you one uh, good example and I'll close this topic. Look at this. Here if I am having boron with a vacant orbital, okay, I am giving you again just for neatness. Boron, if it is having one hydrogen, one vacant orbital, these are the bonds. Is it aromatic or not? It is aromatic. How? Double bond, single bond, double bond, single bond, double bond, single bond, vacant orbital, then single bond. Because of this vacant orbital, this is in conjugation, this is in resonance, so it is going to be aromatic. Because number of pi electrons are 6 only, so this is going to be aromatic. one very special case. Hope